Okay, in this section, we're going to be looking at calculation basic measures of center. So, from the last one we were doing statistical notation, we already got a head start on this one, and we were looking at the mean. So the mean is found by adding together all the data values and dividing by the sample size. So, again, working with our class pulse rate data, we got the mean of 68.2 after applying our rounding rule. Now, the median is the middle value number when all the data values are placed in order of increasing magnitude. So, go through with your data pulse rate data, put it in order just like I have it here, and you'll notice that you have two numbers that fall in the middle. So, if your n is an even number, then you're going to have two numbers in the middle, and this means that you will then need to take those two numbers, add them together, and divide it by 2. In this case, we still get the same median of 68. The mode is the value that occurs with the greatest frequency. Again, if you look at putting your numbers, your data values in order, you can see that this particular sample set has 4 modes. So we have 66 occurring twice, 68 occurring twice, 70 occurring twice, and 72 occurring twice. So when we're looking at this one, this means that this is what we call a multimodal distribution. Let's take a moment and take a look at this. So here we see on the right is a multimodal distribution. It would be somewhat similar to what we would be seeing with our class pulse rate data that we've been working with. On the left is a bimodal distribution. So if we're getting multimodals or bimodal distributions, especially with a really large sample size, this may indicate that you've actually got several subsamples all shoved together. So if I got a bimodal distribution, the very first question I would be asking myself is whether or not I actually have two different groups that I'm shoving together, each of those groups producing their own measure of center that's relevant. So these would be important things to do when you're working with your data. Remember, that's what we do. We plot these data out, we look at our histograms and our frequency distributions in order to ask good questions about our data. If we're not doing this, it's really easy for us to just run a calculation, for example, this bimodal, and I'd get a mean that would be just about in the middle. So it'd be somewhere probably around 45. Looking at that as an eyeball. As you notice, though, that 45 is not actually a good predictor at all. So that would be a really terrible mean to use if I was going to go through and do future calculations. This is why you should always plot your data to look at it carefully before you move too far forward. All right. Our last measure of center here is the mid-range. The mid-range is the value midway between the max and the minimum values. So to get this, we simply take our maximum value, add it to our minimum value, and divide it by 2. In this case, we get a mid-range value of 68. All right, so here's all of our measures of center from our class pulse rate data. Now we want to ask ourselves, what is the shape of this distribution? So, looking at the 3 possible shapes of the distribution that we have over here on the right-hand side, pause for a minute and take a look at this and figure out which one of these 3 distributions is a roughly accurate representation of the data we've got. If you're not sure where to start, focus on the locations of the mean, the median, and the mode. Pause the video for a moment, make sure you've got that down for yourself, and then when you're ready, turn the video back on and let's check it together. All right, in this particular case, looks like we've got pretty much a normal distribution. So we have a mean of 68.2, a median of 68, and one of our modes at least is a 68. So we've got a pretty symmetrical distribution here. Not too bad. Now, the next thing we need to think about is the resistancy of various measures of center. So what does it mean if I say a measure is a resistant measure of center, or that it is a non-resistant measure of center? Take a moment and review this in your text where they go over it, and then when you're ready, turn the video back on. Let's go look at this together. All right, a resistant measure of center means that a single extreme value, such as an outlier, does not substantially change the measure of the center value. So all of these are measures of center. Some of them, however, are more resistant to being pulled out of shape by a single outlier than others. So we need to look at this, and we're going to explore it by adding in one more data value. So we're going to add in, let's say we have a student that has added into the class and they have a class pulse rate of 158. So this is someone with stage 2 hypertension. So although this is a very far value out from the others, it is an actual possible value for somebody's pulse rate. So take a moment, pause the video. You need to go through and recalculate the mean, median, mode, and mid-range, each adding in this 158 for our new sample. All right, so we got our new data value. And when you're done with that, turn the video back on and move on to the next slide so we can look at it together. Do not simply skip this step. Having some practice going through and doing these calculations and then being able to check them back with the narrated PowerPoints is a really important part of understanding this information because you're working with it. All right, so here's what we get. Our original class pulse rate data is a mean of 68.2, median of 68. There's our 4 modes and our mid-range of 68. The class pulse rate data added with 158 added to it, we get a mean of 69, a median of 69. Our modes don't change at all, and our mid-range becomes 109. So, which of these measures of center were affected the most by a single extreme score? Well, our mean changed by 0.8 points, our median changed by 2 points, and our mid-range changed by 41 points. So the mid-range was obviously really affected by the single outlier, and the mean and the median were also shaped by it. Actually, correction, median changed by 1 point. Sorry for that mistake. Now, which one of these were the least affected? Well, our modes didn't change at all. So, when we're looking at this, why does this matter? Well, it matters because the effects of accuracy and prediction of future values. So we use statistics, one, to measure what is. That is important. We need that for a baseline if we're going to look at changes that occur in the future. However, we also often want to use statistics to make a prediction for what will be in the future. Okay, so knowing what my sales are now is one useful thing. Being able to make a prediction about what they're going to be 3 months from now is also another important piece of information and helps me make appropriate plans. So, if I'm using a measure of center that is easily affected by a single outlier, that may undercut the accuracy of my predictions. So traditionally we use the mean in our calculations. So if it is off, so will be our calculations. So we need to pay careful attention to this. Now, let's take a few more minutes here and we're going to do a little bit of comparing and exploring between means. This is really what you do when you get data. You're going to look at it, you're going to make comparisons, you're going to ask questions. You might do some further calculations to help you get better understanding of what you're really looking at. So here we have three pulse rate means. We have one from the class as is, which is 68.2. We have the one with the added person with second stage hypertension, which is 69. Interestingly, the USA pulse rate average for your class age is 70. So when we're looking at this, what might explain the fact that the class mean is much lower than the national average? This is where we go back and we explore our data a little bit. And these are the kinds of questions you ask yourself when you look at this and you go, that's an interesting difference. What might be going on producing that change? Well, what happens is in this particular class that I got this pulse rate data, we had 5 athletes and they were all in their game season. This means they were all in very good shape. So athletes tend to have slightly lower resting pulse rates. They have a more efficient heart. So if we take these 5 individuals and we block out their data, which were in fact all the lower scores, notice this is why we like to keep demographics on people. What are we looking at, right? We see that the remaining data gives us a mean of 70.2, a median of 70. Our modes stay the same. Notice none of those changed, right? And we get a mid-range of 70.5. So, now we go back and look at all of these. Now we have the class of the 5 athletes removed as at 70.2, which is much closer to the USA average. What this tells me is our class pulse rate of 68.2 might be used as a representation of students attending a smaller college, but perhaps not those attending a larger college. In smaller colleges such as St. Francis, you have more students that are also athletes because you have a smaller overall student body to draw from. So keeping in mind in this class, we have 5 athletes. It's actually unusual for me to teach a class at St. Francis that does not have 1 or 2 athletes in it. That would actually be pretty unusual. However, when I was going to the University of Georgia as a student, which is a much larger school, we could easily be in a classroom of 100 people and not have any athletes in it. So when we're looking at this suggests that our pulse rate might be representative for students from a smaller college, because there are fewer students overall in the population. More of them are playing on college teams, and thus they're going to be having a slightly lower resting pulse rate. These are the kinds of things we look at with data to be careful about what conclusions we can draw and what our sample may be representative of and what it's not. Next up, we're going to be looking at some practice problems and how we can use them to help us answer we can use measures of center to help us answer specific types of questions.